This is a demonstration of a magnetostrictive level sensor manufactured by MTS. This particular model is the Level Plus, the M series model. And as I said already, it is magnetostrictive. The way it works is that it has a float that floats on a liquid level. Normally this rod would be in a vertical orientation in a tank that contains some liquid, and the float rides on the liquid level. Inside the float is a magnet that imparts a magnetic field to the metal rod. Inside the blue housing is an electronics package that passes an electric current pulse through the center of that rod at occasional intervals. When the pulse goes through the rod, it creates a circular magnetic field around the rod. That reacts with the stationary static magnetic field from the float, and it creates a torsional stress in the metal of the rod. Now that stress propagates as a stress wave out in both directions from the location of the magnet. At this end, there's a dampener that dampens out that torsional vibration so it doesn't reflect back. But there is no such dampener over here. It just travels along the rod, and that torsional vibration is detected by the electronic package. Now, since the speed of sound in that metal rod is a known fixed quantity, the time of flight that it takes for that torsional pulse to make it along the length of the rod indicates how far down the rod's length that float is located. So, the electronics package sends out an electronic pulse and waits and times how long it takes for the torsional vibration, that torsional sound wave, to move through the rod and be detected. And that indicates the level in the tank. More properly, it's the amount of ullage, the distance between the float and the top of the tank where the electronics package is located. I have a meter connected to measure voltage drop across a 250 ohm resistor, a pair of 9-volt batteries to provide loop power for this 4 to 20 milliamp transmitter. What I'm going to do here is show you how that voltage goes up and down, representing current going up and down as the float is moved. I'm going to take the float and move it down towards the end, representing low level. We come over here to the meter, and we see the position of the needle right there, which is a little over 1 volt on the scale it's at. As I move the float up, I'll move it up, you can see the needle jumps. Move it up again, see the needle jumps. Move it up again, and so on. If I move the float down the rod, you'll see the meter start to go down in voltage. I move it down, and down. And you can hear there's a time delay between the time I move the float and the time you see the meter needle react to that change. That tells you that this electronics package here is not continuously measuring the level or position of that float. Instead, it's sending out those interrogation pulses on an interval, in this case, a relatively slow interval. The interval being, looks like about a second or so of time. So if your process can withstand that amount of dead time, it's great. But just be warned, with the transmitter configured as is right now, it is not an instantaneous level measurement. Most importantly, I want you to see the effect of moving the float on this magnetostrictive level sensor and seeing the effect it has on that voltage. So we see we get an electronic measurement of the float's position, which of course corresponds to the liquid level in the tank.